Rob, and I'm going to be taking you through this example of using the k-nearest neighbors algorithm to detect user anomalies. Let's start off by retrieving our data set. Go ahead and click the second link and then redirect, and that's going to take you to this web page. Scroll to the bottom. Let's open the N10 S10 folder. Then you'll see the N10 S10.csv file, and scroll over here and click download, and that'll download the file. The dataset contains 30 feature vectors and a label vector. This data was recorded from an internet traffic probe that recorded 3 different data points each second. The first thing recorded is the total number of short commands where the response is contained with the window. The second is the total number of TCP packets sent from the server to the client that are not part of the short commands. And the third is the total number of packets sent from the client to the server that are not in the short commands. These features represent control commands, read commands, and write commands respectively. This dataset contains mostly samples that were recorded under normal user activity. These vectors analyze file activity over a network, and our goal is to find any abnormalities that do not align with normal user behavior. Now we are going to open the Google Colab notebook that can be found by clicking on the first link. Go ahead and do that. I'm going to scroll to the top, and this first cell contains all the imports that we are going to use on our project. Go ahead and run it. We're going to use pandas for data frames, which make it easy to manipulate our data. We're going to use NumPy for matrix operations. And lastly, we're going to use a couple sklearn imports for our KNN algorithm and to split our data set into training and testing sets. The second cell is going to import our data, import our data into a data frame for us. And then the second line is going to show us what it looks like. Make sure that you change the content of the first line to reflect where your data set is stored. Go ahead and run this set, and it should look something like this. The next cell is going to split our data into 2 separate data frames. The first being our X or feature data frame, and the second being Y or the label data frame. It is then transformed into training and testing sets using sklearn. Run this cell to split the data frame into these separate data frames. The next cell is meant to show the diversity of the data set. Go ahead and run this cell. This shows that there are 24,733 different user events and 14,261 non-user events. Our goal is to be able to identify which events are user events and which events are not. The next cell is a function that we will use to find our estimated optimal k value. Go ahead and run this cell. Our next cell will call the function we made previously, and this is going to return a rounded value of the square root of the size of our data set. The size of our data set is just going to be the length of our X data frame we made earlier. We will then use this K that we just found in our KNN classifier and use the training data set to create a model. Run this cell to fit the data to the model. The last cell will assess the accuracy of the model. A Y predicted value is created with the model by making predictions according to the test values. Then a confusion matrix is created and analyzed to print the accuracy. Run this final cell to assess the accuracy of our KNN dataset. I'm going to go ahead and do that now. This is going to show us how accurate our model is. From this, we can see that our model is about 97% accurate, which is pretty good.